Good morning, friends. Now we are going to discuss the important problems and expected questions, important questions in OR. This is a part 1. In a standard form of general LPP, where the objective function is of maximization type, and these are the options they given. All the constraints are expressed as equations, RHS, right hand side of the constraints, each constraint is a non-negative. All variables are non-negative. Then the options are given. 1 and 2 are true. Option B, 1 and 3 are true. Option C, 2 and 3 are true. And D, all are true. Before going to that, choose the option, you should be clear of the characteristics of standard form. Because if any question is given other than this in examination, you've been supposed to answer that. That's the reason first you should know the characteristics of a standard form. The characteristics is the objective function should be in the form of maximization type. Yes, the objective function is what? Maximization type. Then all the constraints are expressed as equations. Equations means the constraints may be given in the form of less than or equal or greater than or equal to whatever they given. You are going to express as equation by using a suitable slag or surplus variable based on the given constraints. So here all the constraints is expressed as equation. Yes, good. That third point, RHS of each constraint is a non-negative. Then the characteristics are coming in this, and all variables are non-negative. Yes, here the basic characteristics of the standard form is given 4. In this question, all the 4 is coming what? One by one. Therefore, in the given option, that option D is the what? Right for the given problem. Because of that, the standard form is these are the characteristics. Here all the characteristics are given one by one. The option is given all the 3 are true. Yes, all the 3 are true because all the 3 is coming in the what? Characteristics. This is the basic characteristics of standard form of what? LPP, linear programming problem. And the continuation. Consider the following linear programming problem. They given one LPP, okay? To form the initial simplex table, the number of artificial slag variable to be added is artificial and slag variable. See, when we have to introduce the artificial variable, when we have to introduce the slag variable, first you should know that you be very clear in this. So now here, if the constraint is coming less than or equal to type, we are going to introduce the what? Slag variable. If less than or equal to comes, introduce the variable is called what? Slag variable. Or greater than or equal comes, you are going to introduce a variable is called surplus variable or surplus variable never comes alone, plus we are going to introduce what? Artificial variable. Okay, now here in this constraints, if you are going to see the given problem, one is coming what? Equal. So in these places you are going to introduce a variable is what? Artificial variable. Here we need the variable is what? Artificial variable. Here greater than or equal times, if greater than or equal to comes also, here you are going to introduce the variable is what? Artificial variable plus surplus. Less than or equal to comes, you are going to introduce the variable is what? Slag variable. So totally how many variables you need in this? 3 variables. Therefore, the option A is what? Here, to form an initial simplex table, number of artificial slag variable to be added is artificial, slag variable. Artificial comes in this 2, slag comes in this third one. So therefore, that 3 variables to be added in this problem. Similarly, the following problem they given minimum of z is a number of artificial variable used to solve the following linear programming problem. The last problem I told you, if that the constraints comes greater than or equal to type, only you are going to introduce a variable is what? Artificial variable. Here only you need this constraint is coming in the form of what? Greater than or equal to type. If greater than or equal to type comes, you are going to introduce the variable what? Surplus along with what? One artificial. Artificial never comes alone. Do remember that. And a less than or equal to comes, you are not introducing the artificial here. A greater or equal to comes, you are going to introduce a variable is what? Artificial. So now in this places, how many artificial we need? Greater or equal to comes, only we are going to introduce the artificial along with the surplus. But they are asking the question is only the what? Artificial variable. How many artificial variables you need in this to solve the linear programming problem? See here, the greater or equal to constraints comes only the 2 in these places. Therefore, you need that artificial variables, 2 variables only we need to solve the problem of LPP here. And in in a PERT, P-E-R-T, Program Evaluation Review Technique Network Analysis, if TP, TO, TM, that is optimistic time, pessimistic time, most likely time. In PERT only they are going to give the timing in three format: pessimistic, optimistic and most likely. By using this only you are going to find the expected time, that is called TE. Now here they given the three timings. By using these three timings only you are going to find the expected time. But here the option A contains only 2. Here the option C contains only 2. Option D contains only 2 times. But here option B only contains all the 3 timings. This is the right formula to find the what? Expected time of the given activity. Therefore option B is the right answer for this given problem. In a network analysis, the path takes the longest duration is called longest duration. So what is called longest means it's a very toughest one. It's not a shortest path. Critical is analysis. CPM, critical path method, is always analyzing the critical path only. So that is called the longest path. Therefore it is called what? Critical path. So it is not an ordinary path, it is not an ordinary path, it is not a path between the two activities. None of this. The 3 is wrong. Only a network analysis path takes the longest duration. Longest indicates a critical, toughest one. So this is called a critical path is the right answer to this given problem. Now, if the total float of an activity 3 to 4, they given the activity is 3 to 4. So is 3 to 4, 3 is one even number, 4 is another even number. So 3, 4, they given the activity like this. 3, another one is what? 4. So now this is a head, this is a what? Tail. This is a what? Head. This is a what? Tail. This is a tail even, this is what? Head even. By seeing this arrow mark only you can define which is a tail, which is a head. So by connecting these two only you have the activity. So this is the activity they given 3 to 4 is 18. And this duration they given. Duration is what? 18. Latest and earliest occurrence of the event 3 and 4 are 15, 12 and 22, 10. So you are going to find that the float. Before going to float, we are going to find that each activity latest and earliest. So now 3, who's the latest and earliest? That combination comes like this only. The combination comes L, E. L which indicates the latest, E which indicates what? Earliest. To find that we are going to find that earliest 2 timings of each node. For the 3, whose earliest and latest and earliest is what? 15, 12. For 4, whose latest and earliest timing is what? 22, 10. This is the given problem. Okay, the given problem only are represented in the form of what? Diagrammatic. Now the free float 3 to 4 is what? So now they are asking what? Free float. So I will explain that first. What is free float? What is independent float? So in this problem they ask only the free float. So now I can do directly, but sometimes they may ask independent flow. You must know that how to find the independent float also. Now here total float, free float and independent floats are correlated. So if you want to find the free float, you should know the what? Total float. And if you want to find that the independent float, you must know the what? Free float. So by using this only you can define the what? Free float, independent float and everything. So now my question is what? Free float. Now they given the total float of activities given. This is what? TF. Here total float of this activity is what? 18. Total float of 3 to 4 is given very clearly what? 18. Now the general definition. This is a general definition. I am not telling about the particular case of this problem. First I am explaining the general definition of this free float. Then we will discuss the particular case of this problem. It will be very clear to you. Now to find out that the free float, to find the free float of ij, I which indicates always what? Tail. J which indicates always what? Head. This is a tail, this is a head. So free float of I to j is equal to total float of I to j. If you want free float of I to j means first you be very clear the total float of I to j. So by seeing this, by knowing this only you can find this one. So now total float of I to j minus slag of AD event. Slag means latest minus earliest of L. Slag is nothing but the difference of L minus E only you can say as a what? Slag. Here, if you want to find the free float of I2J means before that you be very clear what? Total float of I2J and the slag of AD event. So which is head and which is tail? I told you very clearly this is a tail. By seeing this arrow mark only you can define that this is a tail, this is what? Head. So now we want what? Free float of 3 to 4. So that free float of what do you want? 3 to 4. So if you want to know the free float of 3 to 4 means first you be very clear the part of what? Total float of 3 to 4 minus L minus E of what? L minus E of what event? L minus E of head event. L minus E of what? Head event. So now here total float of 3 to 4 they given the problem itself. This is a what? This is a total float of 3 to 4. Now here we can copy the same. Total float of 3 to 4 is what? 18 minus L minus E of head event. Head event this one. L, this is L, this is minus V. L minus E. So now 22 minus 10. So you are going to find the difference of this. Now here 18 minus this is what? 22 minus 10 is what? 12. 18 minus 12 is what? 6. Now here 6. Option D is the right answer. Option D is a what? Free float of 3 to 4. Suppose the asking sir independent float sir. How to find the independent float? Here nothing independent float. If you want you must know the free float of that one first. So by using this 6 only you can find the what? Independent floats. 6 minus slag of tail event. Tail event means what here? 3 is a tail event. 15 minus 12. 6 minus 15 minus 12 is what? 3. 6 minus 3 becomes 3. 3 become what? Independent float of 3 to 4. So now if the question comes free float or independent float, so you must be very clear the definition of the free float and the independent float. By knowing this only you can find the independent float and also what? Free float. Free float if you want, first you are going to write the what? Total float minus slag of the head event. Slag means the difference of L minus E. L minus E of the head event. Head event is what? 4. 22 minus 10. 22 minus 10 is what? 12. 18 minus 12 become what? 6. This is the answer for this given problem. Now is one question from the queuing theory. Pure birth process. Here they given only the pure birth only given. Birth. It is not birth and death. They are mentioning is the pure birth. Okay. So here birth indicates only the arrivals. Okay. Now, so options are given. Pure birth process. Only arrivals are counted. No departure take place. See here. See the options. Carefully read the options carefully. In pure birth process, A. Only arrivals are counted. No departure take place. Only departure takes place. Neither arrival nor departure. Both arrivals and departure. Here the mentioning the word is pure birth only. Birth means which indicates what? Only arrivals. No departure, no death. No death point is mentioned in this. Therefore that only arrivals are counted. No departure take place. Therefore the option A is the right answer to the given one. Now the next question is, in a transportation table, the cost elements of the row are given 20, 5, 7, 16. 4 costs they given. The question is, what is the penalty that will be considered for the row in VAM? What is a VAM? VAM is what? Vogel's approximation method. Otherwise you can say it is a what? Penalty method. To find the penalty, what you are going to find? You are going to find the difference between the two numbers. Difference of first minimum and the next minimum. So here the first minimum is what? 5. The next minimum is what? 7. Therefore the penalty being what? 7 minus 5. This is a penalty. Therefore penalty equal to 7 minus 5 is what? 2. Option B is the right answer. Penalty means difference between the first and the next. So difference between the first and the next. Second minus first. The result is second minus first. In this row, 25, 7, 16. These are the four costs they given. First minimum cost is 5. Second minimum cost is 7. 7 minus 5. So that here the penalty is what? 2. Option B is the right answer for the given problem. The next question is, a graphical method is usually used to find the solution of a linear programming problem LPP if the objective function contains 2 variables, 3 variables, 4 variables, only 1 variables. Now I told you in the last video itself, the graphical method is advantage and disadvantage they explained. So here the graphical method is one function contains only 2 variables if possible to solve the problem. It contains only 2 variables. Because that graphical, you have only 2 axes. Here x1, if you are considering, this become what? X2. If it is x, this is what? Y. So in graphical, if the problem is having only 2 variables problems only possible to solve in graphical, especially that what? The graphical, that's the advantage. Advantage means easiest method to solve. Disadvantage means here you can't solve more than 2 variables. That's the main disadvantage, limitations. Therefore that in graphical method you can solve the LPP if it has only 2 variables involved problems. Okay, now the next one is the transportation. This is the question they repeatedly asking in this in competitive exams. In a transportation problem, if the cost of the matrix is what they given m cross n, m which indicates what? Row, n which indicates column. The solution is non-degenerate if the number of allocated cells is equal to m plus n minus 1 equal to number of allocated cells. This is a condition for what? Non-degeneracy. Non-degeneracy condition is m plus n minus 1 equal to number of allocated cells. M which indicates number of row, n which indicates what? Number of columns. The question is given is what? If the number of allocated cells equal to m plus n minus 1. Now, next one problem is value of the game. The question is comes what? Value of the game. The question comes like this, is easy to find. Here you are going to use that value of the game. We have one formula is there, V equal to the cross multiply. Here I can generalize formula, right? Then I will come to the problem. AD minus BC divided by A plus D minus B plus C. See here? This is what? You imagine like this, A, B, C, D. So imagine like this, then you proceed. AD cross multiply. What is come? 15 minus 2 into minus 2 into minus 2, 4. And this come what? Plus. Minus 2 plus 4. Here the formula is what? Minus 4. Done. Addition. 3 plus 5. 8 minus 2 is what? Minus 4. And minus of minus 4 become plus 4. Therefore become 11 by 12. Therefore option D is the right answer. So whenever the problems comes like a 2 cross 2 to find the value of the game, you must remember the small formula V equal to AD minus BC divided by A plus D minus B plus C. So applying this, you are getting the result is 11 by 12. The total number of basic solution for the LPP. So here the two constants are given. How many variables are given? X1, X2, X3. By using these 3 variables only, the constraint they formed and the objective function also they formed. So the question is the total number of basic solution. So how many basic variables are involved in these 3 variables? So by using these 3 variables only, you can define the objective function result and the constraints also you can find. By using the constraints, you are going to define the objective function that you are going to define by using the basic variable is what? The x1, x2, x3. Those 3 variables are involved. These variables are called only the what? Basic variables. And the next one, like in a previous problem, the similar clue you are going to use. V equal to what? A into D 90 minus 8 into 7 56. So 19 is addition of this. 10 plus 9 19. minus 8 plus 7, 15. So that here 90 minus 56, it become what? 34 divided by 4. So it will come 8.5. So the option A is the right answer. So why I am giving these few more examples to you means this compulsory questions from the game theory is this one. So okay, now compulsory question this is. That's the reason I am repeating you to make you easy in this concept. While of the game, again you are going to use the same concept. V equal to what? AD minus BC divided by A plus D minus B plus C. So applying the same concept here. 3 into 5. 3 into 5 become what? 3 into 5 the same is what? And 15 minus or minus 4 plus 4 divided by, here addition of this become what? 8 and plus 4, that become 11 by 12. The next one is a game with the following payoff matrix. Here the same, you apply the concept. V equal to what? AD minus BC divided by A plus D minus B plus C. AD 6 into 0 what? 0 minus B into C. Minus 3 minus 3 become plus 9, but minus is there in the formula. Minus 9 divided by AD, here 6 minus B plus C. Minus 3 what? Minus 6. Here 1 minus is there. Minus 1 is plus 6. Therefore that will come what? Minus 9 by 12. By simplifying this, minus 3 by 4. So for that option B minus 3 by 4 is the right answer to the given problem. So why I am giving more example to you means it's a compulsory 2 mark questions or compulsory 1 questions there in the what competitive exams in TNPSC or whether you are going to CSIR, whatever exams you are going to based on the BSc mathematics graduation. 1 questions comes from the game theory. This particular one is important one. That's the reason I given more example to you. The continuation of that. Here, which of the following is an integer linear programming problem? Integer linear programming problem. Always the assignment problem is always a what? Integer linear problem. All of this is the right answer, not a primal and dual, not a transportation problem. Integer linear programming is only the assignment problem. Now, in a balanced transportation problem, they given very clearly is a balanced transportation problem. M origins and N destinations. The number of linearly independent constraints is number of independent constraints. So I given the last example also. If it is a M rows, N columns comes, that number of linearly independent constraints should be always M plus N minus 1. This is a non-degeneracy condition also. So this is a condition it has to satisfy what? The linearly independent constraint. The number of linearly independent constraints will come this one. M plus N minus 1. Next one. The assignment problem. Option A is a special case of transportation problem. Yes, it is a special case of transportation problem, only assignment. It can be solved by a simplest algorithm. Yes, it can be solved by the simplest algorithm. Next, see, A and B are true, A and B are false. Now, the A and B are true always. Therefore, option C is the right answer to the given question. Assignment is a special case of transportation, and also it can be solved by the simplest algorithm. And they given that the option C is A and B are true, so that you can accept that A and B are true. Therefore, option C is the what? Right answer to the given problem. And before going to solve the duality part, I want to explain that a few results, important results in the duality cases. The first is important is the dual of the dual is primal. Minus of minus become what? Plus. The same manner we are going to use that. Dual of the dual is primal. Remember this point. Because why I am giving this important one, if you are going to discuss any problem in the duality cases, the questions will come the duality based on this results only. So once you are very clear this result, you can do any problem. They given a duality part. So now the first case is they ask the dual of the dual is what? Dual of the dual is become primal only. That dual of the dual is primal. If one is maximization problem, then the other is minimization. If dual is maximization, primal become what? Minimization. If dual is minimization, primal become what? Maximization. Vice versa only it has to come. Okay. So now if either primal or dual problem as a finite optimal solution, then the other problem also what? As final optimal solution. So if the question will come, they give primal, they may ask the what? Dual. If they given dual, they may ask the what? Primal. So at the time of finding solution, if primal is having optimal and it is understood, dual is also should have the what? Optimal solution. Okay, because dual and primal or what? Vice versa cases. If it has solution, that also should have what? Solutions. Okay, now the next one is what? See here, next one. If either primal or dual problem has unbounded solution, then the other problem has no feasible solution. If primal is unbounded, dual become what? No feasible. If primal is no feasible, dual comes what? Unbounded. This is a vice versa case now. If the primal problem is equality, then the corresponding dual variables is unrestricted. The primal problem is an equality constraints. Here, the time of saying the primal is constraints comes equality cases. At the time of writing a dual, that should come in the form of what? Unrestricted. You can mention the last name is unrestricted. Okay, if a primal is equality constraints, then that in the dual it will what? You are going to mention that the variable in the form of unrestricted. What is the meaning of unrestricted? It may be what? It should not be only greater than, it may be in any form. Okay, that is unrestricted. There is no restriction in the sign. It may be in any. If the primal problem is unrestricted, see, in the dual become what? Dual become what? Equality. If a dual primal is equality, dual comes unrestricted. If primal is unrestricted, dual comes what? Equality. So vice versa cases only. So these are the important points you are going to remember while solving the problem in duality cases. These are the points you should be remember always. A dual is primal. If it is maximum, there is what? Minimum. If it is minimum, there must be what? Maximum. If primal is optimal, dual also optimal. Primal is unbounded, dual become no feasible. If primal is no feasible, dual become unbounded. Okay, these are the important key points I given, because to solve the problem, any problem in the duality, that problem is based on this 6 points only. Okay, now we'll discuss few problems based on this problem, based on this results. Now the problem is duality. Okay, here the given is what? Minimum of z. Minimum of z means that both the cases, both the constraints should have the what? Greater than or equal type. Yes, the given constraint. First, before going to form a duality, you check the given problem is the right format. If it is not in the right format, you are going to convert in the right format. Here, minimum means both should be in the form of constraint should have only greater than or equal to type. Min means greater than or equal to. Max means less than or equal to type. So you check the constraints first, the given problem first, then you can convert. Here, duality. See that the given problem is means minimum of z means whose duality become what? Max. Okay, now first you what? Analyze. You are going to check which is not suitable answer for this given problem. Here minimum of z means answer should be what? Maximum. Here this is not a right answer. Leave that. Okay, good. Now how many constraints are involved in this? 2 constraints. For this you are going to assign the variable is y1. Here is what? Y2. Here that constraints, how many constraints are there in this given problem, that has to reflect in the objective function in the duality. So that 10 into y1, 24 into y2. Here 10 into y1. So this is not 24 into y1. This is the wrong answer. So 10 into y1 plus 24 into y2. First we are going to check in these two. So 10 into y1 plus what? 24 into y2. See that? Good. Now here x1, what is the coefficient of x1? 1. 1 into y1, 3 into y2. Here the first constraint less than or equal to, max comes less than or equal times, less than or equal to 20. The second y1, 1 into y1, 2 into y2, less than or equal to 10. So that the option A is the right answer. Why it is wrong? Here 10 into y1, but 24 into y2. Here instead of 24 into what, we have 20 into y2. That's the reason this is answer is wrong. So that the answer A is the right answer. So to convert to the duality form, first you check that the given question is the right format or not. Then you are going to apply the one by one. The rule we have what we have seen the previously the rule. The rule you are going to apply 1 by 1. Okay. Now if it is a min, the option the next one, the primal should be what? Max. That max you are going to cut. That's the reason you are rejecting this first. Then here how many constraints are involved? That much variables you are going to use in that. So based on the constraints, we have two constraints, the two variables you are involving, two variables you are introducing in this. So right hand side, well, what we have, right hand side into that variable only comes in the objective. So 10 into y1, 24 into y2. That's the reason here only 24 into y2 comes. Here 20 into y2. That's the reason it is what? Wrong. That's the reason we rejected that. Okay. Similarly, here question is dual of the linear programming problem. We are going to find the what? Dual. So if it is a min means, first I told you very clearly, you are going to check the given problem in the right format or not. So that's the given problem is the right format means if it is a minimum of z given, both the constraints should have the what? Inequality greater than or equal type. But here it is comes to what? Less than or equal type. That's the reason first you are going to convert this what? Given problem the right format. So you are going to multiply by the minus 2x1 minus 3x2. Here at the time of multiplying with the minus, that greater than less than or equal to become what? Greater than or equal to minus 4. This is the right format of the given problem. First you are going to convert the given problem the right format. That's the reason I converted less than or equal to what? Greater than or equal to type. Now here it is min z. There dual become what? Max z. Therefore that everything is the max z. Good. Now we are going to for this constraints you are introducing the variable what? Y1. For the second constraint you are introducing what? Y2. So that here min z. Therefore the result become what? Max z. Max z minus 3 into y1. So here minus 5. So this is not there. Here minus 5. This is not there. Here minus 3. Here also minus 3. Good. Minus 3 into y1. And here we have minus 4. Minus 4 into y2. Here plus 4. This is not optional. So minus 4 into y2. Good. And here minus 1 whose coefficient to check. X1 is minus 1 into y1 minus 2 into y2. Max comes whose constraint should have the what? Inequality less than or equal type. Less than or equal to x1 coefficient is what? 5. Good. Then y1 into 1 into y1. Then whose coefficient is minus 3. Minus 3 into y2 is there. Therefore option D is the right answer. So that first you are going to check the problem, the given problem, the right format or not. So if it is not given, first you have to convert the given problem the right format before going to convert in the dual form. And also two more note I given. The dual problem minimum of type minimum z means whose objective should be always in the what? Greater than or equal type. Yeah, given problem is max whose objective should be always or each constraint should have less than or equal to type. Here dual problem objective means each constraint should have what? Greater than or equal to type. Here it is not greater than or equal to type. That's the reason we convert into what? Greater than or equal to type. See here. Then if it is that what? Maximization, the given dual function is objective function is maximization means inequality should have what? That each constraint should have the inequality what? Less than or equal to type. Constraint should have less than or equal to type. Min means greater than or equal to type. Max means less than or equal to type. So this constraints you are going to check. If it comes in this format only, the what? Given problem is right. Otherwise you are going to what? Convert the given problem into right format before going to find the right choice to the given problem. See that primal. If the primal problem is given min z, okay, then dual should be what? Max. See that one simple. If it is min, whose dual what? Max. Here it is what? Where is the max is there? Check first in the 4 options. A whose object is what? Min. So this is not a right answer. B whose object is what? Min. This is not a right answer. D is object is what? Min. This is not a right answer. See that? Here the primal is min means the dual should be in what? Max. First this is the right answer to this problem. Okay? Okay, but it is min means dual should be what? Max. If it is a max means dual should be what? Min. So here the given problem is min, therefore the dual should be what? Max. This is the right answer to the given problem. In the following kinds of floats, which is not used in the network analysis in CPM. I told you in that fourth problem. What are the floats are involved in the CPM? If you're going to consider the critical path method, the floats involved total float, free float, independent float. These are the floats only involved in what? CPM. So that independent involved, total float involved, free float, which is not involved in this what? Dependent. This is the right answer of this. The question is what? Not used. Not used. You are using independent float, you are using total float, you are using free float. So independent float is dependent float is not, or not dependent float alone not using. This is the answer to the given option. So in the following kinds of floats, which is not used, these three floats we are using. This alone we are not using. Dependent float alone we are not using. Therefore, that answer B is the right answer they given. Dependent float is not there in CPM. The number of non-basic variables in the balanced transportation problem. Non-basic variable. So that number of non-basic variable in the balanced transportation problem with row 4 and column is 5 is. Now they are asking non-basic variable. First you find the basic variable, then we will discuss about the non-basic variable. Here, what is the row? Row is what? 4. And the column is what? Row is nothing but m, small m. Here, column is what? N. N equal to what? 5. Now, to find that m plus n minus 1 is what here? This is what? Basic variable. Basic variable. So that m plus n. M. So 4 plus 5 minus 1. This comes what? 9 minus 1, 8. Actually, here 4 rows, 5 columns. So that how many variables are involved totally? How many variables are there? So 4 into 5. That how many variables are involved in this problem is mn. 4 into 5. 20 variables are involved in this problem. In this 20 variables, basic variables, how much is there? 8. Therefore, the non-basic variable. So, non-basic variable is, so m plus n minus 1. So, m plus n minus 1. mn minus m plus n minus 1, which gives what? Non-basic variable. So, non-basic variables formula is mn in minus mn plus 1. Mn is what? 20. 20 minus 8 is equal to what? 12. I will repeat once again. The number of non-basic variable, this is the question you are going to find. The given rows is what? 4. And the given column is what? 5. So therefore, how many variables are involved in this problem means 4 into 5. So 20 is actually involved. So that you are going to find the basic variable. How many basic variable are there in this? 8. Total variable involved in the problem minus the basic variable, which gives the what? Non-basic variable. So that mn minus mn plus 1 minus, which gives what? Non-basic variable. Here mn, how many is there? mn equal to what? 20. 20 minus the basic variable is what? 8. Therefore, the non-basic variable of the problem is what? 12. Here is the right answer to the given problem. So, I'll write it here very clearly. To find the non-basic variable, mn minus m plus n minus 1. This is equal to what? Non-basic variables. So, the mn, which indicates row column, multiplication of row and column minus basic variable, which gives the what? Result of non-basic variables. In the linear programming problem, the number of variables in primal is n. Number of variable in the what? Primal is n. The number of constraint in the dual is m. Yes. Here, primal, how many variables are involved? Primal, say that primal in the linear programming problem, the number of variables in the primal are n, and the number of constraint in its dual are m. So, how many variables are coming in dual? That became a what? Primal. See in this, I will do that here. This is a what? Dual. Here how many variables are there? y1, y2. Here how many variables are there? x1, x2. Here 2 variables. Here also what? 2 variables. That should be what? Here it is n. This is what? m. So now here how many constraints are there? Based on that you are reducing the variable. That variable has become what? Objective functions. I mean that that variable become a constraint to the dual. That here 2 equal to m equal to n. That linear programming problem, the number of variables in primal is n and the number of constraints in its dual is m, means m equal to what? Always n. The dual of the problem as infeasible solution. So this problem is based on the results. I told you that this is important results. Based on that only, the dual of the problem is infeasible solution. Then the value of the objective function is what? Infeasible. Here that problem as the dual of the problem is infeasible. Then the value of the objective function is what? No solution. Infeasible means we don't have any solution. That the value of the objective function should be what? No solution. If they are asking, the primal means unbounded, but the asking is only objective function. The dual objective function. Dual objective function is also what? No solution, because it has infeasible. Infeasible means we can't find the solution. No solution. The next one is queuing theory. The departure and arrivals in queuing system are normally considered respectively as. They given two things. One is departure first, next is what? Arrivals. See the questions carefully. Departure and arrival. So here they consider two things. Two things, not one. So not one means no birth. Birth alone, no death alone. Here birth and death or death and birth. Here departure first followed by the what? Arrivals. Departure, it's the death first, then only the what? Birth. This is the right option. The given problem. Because departure they are considering first, followed by only the arrivals. Okay. If it comes arrival and departure means birth and death. But here departure and arrival means death and birth. Okay, now listen. Queuing description m/m/1 in arrival and departure distribution are m. Here this indicates a what? Server. It's a single server only, but m, this is one is arrival. One indicates a what? Arrival. One indicates a what? Departure. So the arrival m, which indicates the Markovian process. What is Markovian means? That present is that future is based on the only the present existing one, not past data. That future is depends on only the present, the existing one, what you have in the current. Based on the current only you can define the future, okay, not based on the past. That called Markovian. Therefore, when you are going to discuss the queuing theory is fully based on the what? Markovian. That indicates both arrival and departure, arrival and service. Everything is based on the what? Based on the Markovian model only. Therefore, that arrival and departure of the distribution are both m and m is always both what? Markovian model only, not a binomial, not a general, not a none of this. So here that everything indicates both based on the what? Markovian. I told you Markovian means that future is depends on only the existing present data, not based on the past data. That indicates the m. Therefore, that queuing is both depends on the Markovian model. The dual of the dual. So this is also one of the result. I told you that what important in the dual part. The dual of the dual is always primal. Minus or minus or what plus. I do remember that. This is the first important result I given in that statement. The dual of the linear programming problem as a finite optimal solution, then the primal. See here the dual whose result is what? Final optimal solution. Then the primal process also should be what? Finite. If it is finite, then primal also should be what? Finite. Okay. If dual is finite means prime also should be what? Only finite optimal solution. It is a reflection. Okay. That if the primal of LPP has no solution, primal is what? No solution. Then the dual as either no solution or unbounded solution. Okay, here no solution means there's no doubt about that, no solution only. Here another option also they given, or unbounded. Not unbounded, this is not option, this is not optimal solution, this is none of this. Therefore it has no solution means compulsory, no doubt about that. Primarily is no solution means dual also what? No solution. So option A is the right answer to this. So now to answer to this part of the questions, you must be clear in that the standard results which I declared, which I told you earlier, to solve the problems of duality. Kind of do remember that. Shortly we will meet on the next part. Okay, the next video, important expected question of the same OR. I didn't cover all the part, only I taken the only 30 questions that important for the first half. Okay, remaining we have that queuing theory and sequencing and everything we have, that I will tell you in the next video. Thank you. I think it will be useful to you because I taken only the repeated questions and that old question papers. At the same time I referred the TRB and the CSIR old question papers, everything. I had taken the questions from that only. Please you go through carefully and use it. Okay, thank you friends.